Right. Good evening, students. So as usual, most students in online classes, they are watching the recordings without joining live sessions, because then they can watch at any convenient time on any convenient day. But I prefer if you can join live sessions. But anyway, like no issues. Like, okay, we'll start then, students, today for the math class. Right. So then you have the textbook, I think. So we are starting the first unit today. Right, write down. If board all clear, students, my voice and the screen, all picture, video all clear, say yes. If any doubt, any issue there, you can type. Okay, chapter 1, complex numbers. So you turn to the first page. There, before starting this complex number part, we have some simple calculations. We'll go through that. Okay, so try the first question. So what you have to do is, you pick the greatest square number inside that. Then that greatest square number, now inside 50, the greatest square number is 25. So 25 into 2. So because we found the greatest square number, that you can take out, 25 becomes 5. So the final answer 5 root 2. Okay, like that, students, you type your answers for these two. You can, this chat box, you can send your answers. Okay, start. Once you're done, say done, then I can put the answers. So Amit, you know how to use the chat box? No, you can send either answer or you can say done once you finish. Done, okay, right. Once you finish, say done, then I'll put the answers. Done, right. Okay, so then in 180, it is 36 into 3. Inside 180, if you see 9 into 20, That is 36 into 5. Now I'll give a tough one, mixing them. Check whether you can simplify. Okay, give me either you can type the final answer or you can say done. Right? Okay, we'll see the answer. This is 9 into 3, so 3 can take out. This is 25 into 3, 25 taken out as 5. This 36 into 3, 36 comes out as 6. So what's your final answer? Yes, good, good. Very good. Okay. Right, now students, we'll see another type, that is number of fruits. In a question, they can ask the nature of fruits or number of fruits. Now, this is the theorem now. So in the equation ax squared plus bx plus c, the discriminant. Now for discriminant, the math symbol is delta. This is called capital delta sign. We know simple delta sign also there. Like this capital delta sign. So then simple delta is like this. Right? So then this is standardly using delta. So delta answer is b squared minus 4ac. B is the coefficient of x. A and C are these two. So then there's a theorem, if delta greater than 0, roots are real and distinct. Distinct means different. So you are getting two different roots. So the number of roots two, right? Number of roots 2. number of real roots. So if delta equal to 0, roots are real and coincident. That means same root repeating. Same root repeating means you can't say two roots. Same root repeating. So one root getting. So number of real roots, two getting, but both are same. That corner you can see, right? So then if delta less than 0, roots are unreal. Imaginary. So therefore number of real roots answer 0. If both roots are imaginary, number of real roots 0. So number of roots answer should be 2, 1, 0. Nature of roots, they can be real, these both real. To get real roots, delta can be greater than or equal to 0, both. Real and distinct only greater than 0. Real and coincident only equal to 0. Imaginary roots, delta less than 0. So those are the theories. So now next thing we are going to do number of roots. So you have to check delta and say, if positive answer comes, you say 2. If 0 comes for delta, you say 1 real root. If negative answer comes for delta, you say 0. Number of real roots always 2, 1, 0. Okay, copy this and give a try. There are 3 questions asked. Okay, you give a try. First copy. Once you finish, say done, or you can put the best thing. A, number of fruits, say 1, 2, or 0. B, you type, C, you type, then I'll put the answers. Once you put the answers, I'll try. Okay, we'll see. So this is getting 64 minus 120 minus 56. Less than 0. So number of roots 0. Number of real roots 0. So what's your answer? Correct. Now this one, delta. (81 minus 56), that is 25. So therefore, number of real roots 2. Correct. This one, right, all answers correct. Now, because all the other students, most of students joining, they are watching the recordings. If it's possible only, otherwise no issue. If it's possible only, it's better if you can add a screenshot to the WhatsApp group, not to the general group, further maths group. If it's hard, that's fine. We'll see whether it's possible. If it's hard, no issue. To the further maths group, if it's possible, you can add. Seems it's hard, no? That's fine then. We'll move to the next part. Okay, that's fine, no issue. Okay, I'm going to erase, no issue. Right now, we are going to try this now. Took a screenshot. Later even you can add. Yeah, that's fine. Okay, thank you. Later even you can add. Okay. Now, if you have this cal FX991, this black one or the gray one, that's fine. That's the correct one. Any other cal, if you have even, okay, now we need cal for the next calculation. In the calculator, you need to do some calculations here for trig question next. So we'll see. Right, students, we'll see X1, question number 3. So in the question asks, find x and theta. Now, students, to find x, no need the calculator. You can use the Pythagoras rule. So x, you put the answer that you can type now. Theta you can get in degrees and radians. There are two measures, degrees and radians. Both you can get in the cal. Right? Okay, you can try now. Last answers, if you put the unit enough. Tan theta is opposite to adjacent. So if you have the calculator, you put answers. Otherwise, I'll give a try. If you go to the radian mode and see, this answer comes 1.176. But yeah, 1.176. Usually we are leaving the answer in terms of 3SF. So 176, no, 6 is more than 5. You are adding 1, and you can say this is 1.18. 3SF. Now you put the degree answer. Go to the degree mode. What's your answer? Yeah, 67.38 comes. That is correct to 3SF. Answer is 67.4 degrees. Okay, very good. Right. Okay, now we'll move to the question number 4. Now we are going to try using the formula. We are going to write down the answer. Now earlier we checked number of roots in a quadratic equation. Now formula. This is the formula. Formula this. So using this formula, you get the answer. So I'll put book question and another question. Actually, this one, yeah. Now I'll put another one. Right. You put answers for both. If it is hard to type, you just say done. Then I'll put the answers and you can check if answer same, you can say yes. Okay, if it's hard to type. If you got the same, you say yes. Now you can try the second one. Yeah, now in this question, the issue is they have asked in third form. This is called third form. So it's not good to write down the answers in decimals. Better leave it like this. That's the proposal in the question. Both A and B should be integers. So you have to put the answer. So then this is in the form A is 4, B is 10. Like that in the question, proposal is that. Okay, give a try for the second one. You tell me A and B values, then no need to type like this. If you can say me the integer A and B values, enough. And this one A and B sometimes be fractions. In the question, just this given, no? This we got A and B integers. My question, I didn't check, no? This one probably you will get A and B as fractions. That's anything fine. Okay, you type the answers. Okay, we'll see. Okay, give me 1 second. Right, we'll see. Now this one. Here 16. This is getting 96. 96, 16 added because minus minus plus. So 96 and 16, once you add, 112 comes. So then root 112 over 6. But root 112, if you divide by 4, it will be getting 28. 28 again you can divide by 4, that is 7. So 16 into 7. So that is 4 root 7. So the answer getting so this time answer given in this form. So if I propose this as A plus or minus B root C, where AB rational, C integer, then you answer A this, B this, C is 7. This question they propose AB integers. So this I'm going to propose AB rationals C integer. Okay. Idea got no? Right. Yes. Okay, so then you copy. After you finish copying, you take a screenshot. Later you can add. So once you finish everything, copying and taking screenshot, everything, you say done. Then I'll move to the next part. Once you finish all, say done. Done. Okay. Right. Then question number 5, you can give a try, that is just rationalizing the denominator. How to rationalize? You are multiplying by the conjugate. You give a try. Yeah, then I'll put another one. So I think that rationalizing the denominator, you multiply by the conjugate of the denominator, then denominator getting a nice value. That is called rationalizing the denominator. In top, you will have rational value. That is fine. Give a try. I'll put another one. Screenshot taken or later you can add. Yeah, no? So I'm going to erase them. Okay. Right. So if you found P and Q, you type, then I'll give another one. So this is the treatment. You should multiply by the conjugate. Conjugate means the same thing, sign opposite. If here minus, here plus. If here plus, here minus. But top and bottom, you should multiply by the same thing, conjugate. So now you get the answer in this form and express your P and Q values. P is 28. We'll see. Q also you type. Q is 7. Okay, we'll see. Now here P and Q rationals. That I think mentioned in the question. Yeah, P and Q are rational. So then your top calculation correct, but you miss the denominator. 16 minus 3. Middle part not getting by the conjugate. A square minus B square getting. So 16 minus 3, 13. So your answer idea getting right. Okay, top part correct. This one you miss. Now give it another try. This one. Okay, give a try. Okay, we'll see answers. Here plus no, so you have to take minus also inside. Yes, perfect. Right, good. Now, students, we are going to start the actual lesson now. The lesson is lesson called complex numbers. Complex numbers means if you divide the total number set, you have real numbers and imaginary numbers. So, if there's a way of writing both parts together, that is called a complex number. Even one part there, we can say a complex number there. Now, this is the definition. Okay, now look. Okay, now look, complex numbers. Complex numbers means the total number set. This is called the total number set. So real numbers and the imaginary numbers. Real numbers, imaginary numbers they are. So real numbers means like 5 real, positive integer, negative integer real, 0 real, fraction real, minus fractions real, right? And thirds real. These all real numbers. Decimals real. These are called n decimals. N decimals real. If it's getting say infinite number of decimals, 0.43333, many threes. So you can put a dot here. That indicating threes repeating. Those all real. Hey, this 6-2 part repeating. 6-2 part repeating. So then you have to put two dots. So the number will be minus 2.162, 62, 62, 62 like that. So these all real. Thirds real. If you are getting many decimals, that is called irrational. These are called irrational numbers. Many decimals means irrational. These are called rational. So these are rational. If you can divide by a fraction, these are rationals. Rational, thirds, irrational, thirds also irrational. These also irrational, these also irrational. So these all real. So then what we can put for the imaginary? Imaginary means minus number square root, positive square root. Now even here, if you have minus 8 cubic root, that even real. Answer is minus 2. That even real. But minus numbers, square root is imaginary. See, this is imaginary. This is imaginary. This is imaginary. These all imaginary. But imaginary numbers, you have a common feature. In all imaginary numbers, you can leave minus 1 inside. Why? Imaginary numbers means minus value square root. Square root. So minus 1 you can leave, others you can take out. So this one, if you put I to indicate imaginary, I, standard notation, this minus 4 square root, once you take just 4 out of square root is 2, leaving again minus 1 square root, so 2i. That's the common feature in imaginary numbers, always that I, minus 1 square root comes. So then here you have minus 904. 904 you take out, that is 3/2. So we left only minus 1 inside the square root, that is I. Then minus 5/16. 16 you can take out as 1/4. 5 you can't take, then root 5. But still minus 1 square root there. So that is I. So the answer 5 root 5 over 4i. The answer is square root of 5 over 4i. I comes all the time. So that's the feature in imaginary numbers. So imaginary numbers standard is minus 1 is I squared. That's the standard. Minus 1 is I squared. Okay, you copy down this, and after finish copying, take a screenshot. Later you can add. Once you have done everything, you say done. Then I'll move to the other parts. Once you finish all, you say done. After finish copying and adding, taken the screenshot, say done. Okay, done. Right. Then we'll see. Right. Okay, we'll see. Okay, now we can move to 1A exercises. Exercise 1A. So you can try with this knowledge. Question number 1. Try part C, I, J. So real parts you can add together, imaginary parts you can add together. And one more thing. So therefore, now we divided to real numbers and imaginary numbers. No, real part say A. Imaginary part always comes apart from that I minus 1 square root, other part real now again. So this is BI. This also real. This also real. Even though BI part imaginary, now we got earlier, say minus 4 square root. 4 we taken out as 2, so 2 into minus 1 square root 2i. So minus 4 square root, we got 2i. 2 is real. So even though that's imaginary part, this number real, I stand for that minus 1 square root. That's the feature. All the imaginary numbers that I comes. I multiplied by a real number. So then we can get standard form of a number. Now, complex number, the whole number set, total number set, we divided to real numbers and imaginary numbers. Real number is A. Imaginary number BI. Where A and B both real, but BI is imaginary. So once you put together, comes the standard form of a number. So standard form of a number is A plus BI. That's the standard form of a number. Right? So if B0, it's real only. So then we are not going to say complex, but that also a complex number, where imaginary part 0. Purely imaginary. If you got just say, we are not going to say purely real, it's real. But if a part 0, if you are getting just this part, like 2i, just that part, that is called purely imaginary. When both together there, we are saying complex. But these also we can say complex. So complex number can be real part only or imaginary part only or both together. All we can call complex. But generally we are calling this is complex, this is purely imaginary, that also complex. This is real, right? Even real we can call imaginary. Real we can call complex, right? So these all parts, part of complex, right? So now in question number 2 also you can do, when you are adding or anything, real parts you add together, imaginary parts you add together. So I'll give a try. I'll give a chance for you. If it is hard, we'll see. You give a try Dij. Question number 3, when you can give a try. That is when multiplied by coefficient. I think you will manage. Otherwise, I'll explain if it's tough. So you do DNH. Question number 4 onwards. Yeah, after you got these answers, we'll do after that. So now you try, copy these and give a try this part. Here, no need to type answers. Once you just finish, you say done, I'll put the answers fast. Then we can try some tough ones. We are doing FP1 book in 4 months. Every theory book 4 months, 1 month paper. Once you finish all, say done. Okay, done. Right. Okay, we'll see then. You can check your answers. So that is 11 square. So 11i. You can take 100 out as 10, but 2 you have to leave. That is 100 root 2 and minus 1 root is I. Hundred and 47 is 49 into 3. 49 you can take as 7. 3 remains and I there. Right. So now question number 2. Question number 2D. So you can add real parts together. Half plus 5 over 2, 3. 1/3 plus 5 over 3, 2. If any answer different, you tell, I'll explain. This is I now. So minus 2 plus 1 plus 12. So plus 12 plus 1 plus 13 minus 2, 11. Minus 7i minus I minus 8i plus 3i minus 5i. Then you have j. If you have any doubt in my calculations, you tell. Sometimes you may be correct, I may be wrong. Simplification. So you tell, we'll check. So now j. (18) minus 15 minus 3. So 18 completely cancelled. 5i, 2i, 7i minus 7i all cancelled. Answer 0. Okay, now we'll see part question number 3. D. So find for 20, here plus 4, 24. 15i minus 8i, 7i. Then h. So now, once you take the 4 as the LCM, this will multiply by 2. Then 14 minus 8 minus 14. That will be minus 22. Minus 22 over 4. That is minus 11 over 2. Then Here, if you take 4, this will be 4. Minus minus plus. Plus 4 plus 3 plus 7. 7 over 4. Answers matching or different? Same. Okay, good. Okay, now we'll see. Now rationalizing. See question number 4a. Question number 4a. 4 minus 2y over root 2. That is, you can directly do the rationalizing because 4 is 2 into 2. 1, 2, you can write down root 2 into root 2. So 4 is 2 into root 2 divided by 1 root 2. 2 root 2 remains. Again, this 2 is root 2 into root 2. 1 root 2 cancel. Root 2y. But next one, you have to multiply by the conjugate and do. So part B will be tough. You have to multiply by 1 minus root 3. Then you should simplify. So that will be little tough. 1 plus root 3, 1 minus root 3 is 1 minus 3. That is minus 2. Then here you have this. So then this 1 minus root 3 part just keep. Real part comes 2 into 1 minus root 3 over minus 2. So 2 and minus 2 cancel, minus 1 remains. Because of minus 1, you can change the sign. Root 3 minus 1 is the real part. Minus 6i over minus 2 plus 3i. So plus 3 into that is the imaginary part. Are you there? Okay. So you can copy down those two parts and you can give a try. You can give a try. Question number 6, 7C. After copying this part, and question number 8. Okay, that's all. So these you can try now. So first you check these answers. I think all same. This you copy. Then you take a screenshot at later. Then give a try this. Okay. This I can erase now, no? You finish copying and you are trying these questions. Screenshot taken, okay. Right, once you finish these, say done, then I'll put answers. Or if anything tough, you can ask, I can explain while you are doing. Once you finish question number 6, say 6 done, question number 6 done. Six done, okay. And if you can type A and B also good. Okay, check whether these are the answers. Check your answers. So just the imaginary part. Because real part 0. Here imaginary part 0, so always real. Okay, for homework, you do all the remaining parts in 3A. Next day we can speed up. And you can check answers with the book. If doubts there only, you can ask. No, otherwise no need to ask. If all matching with the answers and if you got the idea, even though if you went wrong even, if you can get the idea with the book answers, then no need to ask. Doubts only you can ask. Next day we can continue. So usually first chapter takes 3 lessons. Okay, because this is lengthy one. Some short chapters there in this further maths one, those 2 lessons. So finishing in 16 lessons. That is 4 months. Remaining means the questions we skipped. Okay, now take a screenshot. Later you can copy and check. So once you have taken the screenshot, I'll end the session. Once you taken the screenshot, say taken. Okay, taken, right. Okay then. Okay, right. Okay, good night. And other classes, you check the common general group. I'll put all the times and all. So most students in this online, they are joining recordings. They are watching recordings. Some students, they feel this 8 to 10 is too late for them. Most of girls and all, that's the issue. But this is the only time I'm available. So I asked them to watch repeat. So no issue. If you can join live, good. And other classes, all I'll put messages to the general group. Okay. Good night then.